Hello YouTube. Today we have another laptop to repair. This time one of these fancy ASUS Zephyrus laptops with the dual screen stuff going on there. The customer said this one really?
For more accessibility features, press Windows and U, or select the accessibility icon in the bottom corner.
Okay, so the customer says that this one is a no power unit. They can feel it a bit staticky on the back lid, but there's no response to the power button. So let's plug in a charger and just confirm that that's the case, and that's true. The charger is in, and the system is dead. Can't see any lights on it, nothing to indicate that it's charging. No LEDs anywhere, so let's pop the case off. It looks pretty clean. It doesn't look to have been messed with too much, which is good. So, with every no power unit, I'm going to want to start on finding the main power rail and checking to see if that's present, and if it's not, we can check it for short circuits. So let's get you under the microscope. So I'm looking for a coil, followed by a chip, followed by a cap. Now this cap is going to send 19 volts into this chip. This chip's going to work some magic, and then it's going to send a lower voltage out of this coil. So we can find our 19 volt rail just before this regulator. So let's switch to voltage measurement and see if we have 19 volts of that coil. So one probe on ground. We have nothing. Okay. Okay, I didn't expect that. So unplug the battery and the charger. Go back to resistance and see if that coil is measuring short to ground. So one probe back on ground, back to this capacitor, not coil, sorry. Oh, we've got 0.3 ohms. Okay. Okay, so we've got a short on the 19 volt rail. That was a quick diagnosis. Now we've just got to figure out where it is. I'm going to take the heatsink off this laptop, just so I've got a bit better access to everything. And then we can get out the thermal camera, inject some power, and see if anything gets hot. You know what, actually, before I start injecting power, I'm just going to take a look around the board a little bit, see if there's anything obvious. So I'm going to remove this sticker. And I'm going to focus in around the driver Mosfet, so you can see they're a bit greasy from the thermal compound they've got on them, but I'm not seeing any corrosion or anything. Nothing hiding under this sticker. Just some caps. Let's change the polarization on my light to see if anything becomes obvious. Oh, they look okay. Visual inspection's a super important part of repair. Quite a lot of the time you'll be able to find a bad capacitor without injecting any voltage, and that just makes life a bit easier. But I'm not seeing anything exciting, so we might have to get the thermal camera out. Let's check first. Let's check the really key rails that would be problematic if they had a short. So these two coils here, I believe, feed the VRAM 1.2 volts. And you do not want that to be short. That's 27 ohms, that's about right. Then you've got some coils here, which they send power to the GPU core. Naturally, they're going to be super low because it's a super high power chip, so they'll be almost zero. Yeah, 700 milliohms, which is about right. And then over here you've got some CPU coils, so we're interested in the resistance on our CPU coils as well. We're expecting 3 or 4 ohms on most of them. 8, 9, that's fine, as long as it's not 0, 0. That is good news. Yeah, that all seems good. So the reason I'm checking this is what we don't want to have happened is for a driver chip to have failed and sent 19 volts into the low voltage output. So if 19 volts, or if one of these failed and sent 19 volts to the CPU, then it could mean that we've got a bad CPU. But we look relatively okay on this board, which is good news. So let's show you what we're going to do. Go back to a nice point to find the 19 volt rail. And just up here is good. So you've got that regulator next to a coil again, and on the input there's a couple of larger capacitors. So that's where I'm going to inject power. And there's a little jumper, bit of solder there that I can solder a cable to. So let's get a cable soldered. Actually, we're just gonna, let's put it on this cap here. You can see the trace layout. That cap up there is on the same rail as that little point. It's got quite a lot of space around it, so perfect to solder a thick, heavy wire to. If my soldering iron decides that it works. There we go. Perfect. Well, what I'm going to do now the red cable's connected to the bench power supply is I am going to, rather than solder its own ground cable, I'm going to use USB-C as its ground, so I don't have to solder another cable. And that should be all we need to start injecting power. So let's turn the thermal camera on. Once that's booting up, we can spend a bit of time talking about the voltage we want to use to inject. So this is the 19 volt rail, so we can go anywhere up to 19 volts and it will be fine. However, if one of the driver MOSFETs has failed and 19 volts is connected to something that it shouldn't, then what we don't want to do is inject loads of power because that can make the fault worse. So we're going to start at a low voltage. I'm going to say 1.5 volts and we'll put 6 amps into it. And I mean, you probably want to put less than, but yeah, we'll start with 1.5 volts, 6 amps, and see if anything gets hot. And then we can hopefully figure out what's wrong with it. Hopefully it's just a capacitor. It looks to me like this would just be a bad capacitor. Did you guys hear that squeak? Oh. That sure is interesting. But down the bench power supply and listen to this. Wow, okay. Not seen that before. Wow, it's making its own music. Okay. I've never had a squeaky short circuit before. Let me just recheck resistance, because it's drawing power for a second there. But it's not staying on. Huh. That is the 19 volt rail. That is where I was measuring earlier, I think. No. What? Something weird's going on. Okay. So let's see, up here should be 19 volts because it feeds these Mosfets. And this isn't short. Again, this is should be 19 volts, should be connected to these caps over here, so let's measure between them. Yeah. And that's not short either. So, what's going on? Because down here, this cap. Oh. Oh, I'm stupid. This is the ground side. I was measuring the ground side of this cap. 19 volts is not short to ground. Okay, let's start this again. Strange that it squeaks though. Right, let's remove my my cable. We don't need that. I was being stupid. Let's plug our charger back in. And go back to voltage and recheck the 19 volt rail. Yeah, we got 20 volts. Okay, that's fine. So yeah, as I say, I was measuring from this side of the cap to ground when this side of the cap is ground. It's this side that's positive. See that? Yeah, okay. Right, so we have a 19 volt rail, and we're not seeing anything suspicious, but we also have no power button response. Let's probe around at the coils and see if we have any more power anywhere else. Oh, something just fell off my desk. So that coil's output is 0. We've got 1.8 there. That coil has 0 volts on it. And this one's also got nothing. What about this small one up here? Can't get to the coil, so I'll measure the cap, and that's also 0. And there's a couple of coils over here. No volt. And no voltage. Right, I'm going to plug the battery in. This is going to be an interesting test. So, we're going to check if the battery has voltage. And it doesn't. Nothing on the battery at all. Well, very little at least. This is interesting because we have the 19 volt rail, so the battery should have the power required to charge it. But what we might not have is a response from the EC chip or the charge IC. So let's have a couple of I2C lines here which will be pulled up to 3.2 volts. There's one of them. And there's the other. So you probably got 3 volt low power, but for some reason no response from the EC. Interesting. All those coils I just checked for voltage, let's check them for resistance to ground. I'm working without a schematic here, so I don't actually know what a lot of these do off the top of my head. Not sure. Not sure. Not sure. Forgot to remove the battery, so let's unplug that. Not sure. Not sure. Not sure. Sure. Okay. That is definitely short to ground. I don't know what it is, but it's short. So what do we have? We have... Let me untangle my cables. There we go. We have 19 volts coming into this Mosfet here. This is a dual Mosfet. You can tell by the trace layout here. So we've got a gate pin there and a gate pin there. And then it will have some sort of power regulation happening at the output here, which is the one that's short. And then you can see that's also connected up to this little chip here, which looks like a power switch. So for example, if this is 5 volts, then this is 5 volts, but may occur later on in the system power sequence. So you've got like 5 volt low power, and then when the system turns on, you've got 5 VS or something like that. So there's an input there, and you can see an output just on the other side of it where that copper pad is. Let's double check if that's short, and that's not short. So I think this is going to be possibly 5 volts. That's my guess, but I don't know for sure. Now, because we don't know what it is, we don't want to inject too much power. So let's go back to our other approach of putting 1 volt into it, and we can put some current into it and see if anything gets hot. Or we could try and figure out what it is. So if it's 5 volts, then there's a chance that we have the same short circuit around USB, because USB runs on 5 volts as well. So there's a USB switch, and it will have 5 volts coming in, an enable signal, and 5 volts going out into the USB port itself. So what's the resistance to ground on the 5 volt input to this USB power switch? Hey, it's 0 ohms. Okay, cool. So we have a short here and a short here, which means this is connected to this, and we know that this is producing 5 volts to the USB just from its location. So we know that we've got a short on 5 volts, even without a schematic. Didn't take too much to figure it out. Now we can solder our cable back onto the 5 volt rail this time, and see if anything gets hot. So you know the drill here. Cable soldered on. We can ground it out with something connected to the USB-C port. Let's drop our current down. Let's only go for 3 amps. And hit the on button. Okay. Right, my USB-C wasn't connected, which is really good, because for some reason my bench supply is reset to output 19.5 volts. So we just narrowly avoided sending 19 volts into the 5 volt rail, which would have been an absolute disaster. There we go, 1 volt. It's connected up properly this time. Hit on, and yeah, it's drawing 3 amps at 1.5 volts. Thermal camera's still on. There's a lot of reflections on this board. We're just going to look around for hot spots. Let's change the scale so it only sees things that are really hot or very reflective. And I'm not seeing anything suspicious. There's maybe a bit around the DC jack, but I think that's just a reflection of the metallic parts of the board. Okay, let's increase the current up to 6 amps and see if that changes anything. That is just a reflection, isn't it? Can I feel any hot spots there? No. Okay, it's still not showing anything. Let's increase the voltage a little bit. Let's go to 3 volts. And this should be getting hot now. See a bit of heat being generated just around where our ground is. So if we unplug our USB-C, that heat goes away. And that's just because there's quite a lot of power running to ground now. But we can't see anything that's getting hot. Which makes me worry that I've connected. I've done the same thing again, haven't I? No, that's definitely the 5 volt output. So I haven't accidentally soldered that cable to ground, which is good. But I'm still not seeing anything get hot. So what I'm going to do is I'm going to take the board out, do a visual inspection of the underside of the board, and then we can go back to injecting power if we don't see anything obvious. It could also be a peripheral that's causing the problem, so the secondary LCD maybe, or webcam or something like that. Though I think the webcam's unplugged. So it might not actually be a fault on the board. We could just have something else in the system that's shorted out. Oh, there's still a cable attached. Hidden under this Kapton tape. Thank you, ASUS, for that. Okay, the board is out. Let's recheck resistance to ground on that 5V rail. So it's still short. There is no problems with this chassis. Let's actually remove the RAM as well. It's DDR5, so I think it might have some higher power on it. Is it to do with RAM? No. Okay. And it's got a sticker all over the back of the board. And I can see the problem straight away. So let's show you what I'm seeing here. I think the fault is that cap there. Now remember I said there's a bit of heat coming from USB-C because of my because that's where the power was going through. Yeah, it turns out that there's heat near the USB-C because that's where the fault is. So let's just pull the sticker up a little bit. And actually it's probably important that I measure that this is on the same rail. And yeah, that cap that's on the shorted rail as well. So it's safe to say that that's going to be our problem. This is why visual inspection is important. I should have removed the board first and had a proper look, because we wouldn't have wasted any time injecting any power. So this is the USB-C controller, or one of the USB-C controllers, and USB-C is relatively complicated, but it will have 5V near it because it needs to supply USB-C devices 5V. So obviously you can challenge from USB-C, which will be 20V going in, but it also needs to be able to provide 5V going out to power like your memory stick and your mouse, whatever devices that you plug into USB-C. So that's another place that 5V is going to show up, and this one is definitely seen better days. Let's get this cap removed and double check that the short's gone. Let's turn my heat gun up just a little bit. Come on. This cap doesn't want to go. Does not want to budge. There we go. Just add a bit of flux and clean that up a little bit. Now, if I measure between these two, we no longer have a short. We are good. Now, I don't know why the short on 5V would possibly stop the battery from charging, but I have seen it before. It used to be the case that if you had 3VLP to the EC chip, that the battery would charge, but sometimes, I don't know, sometimes I guess it can be a fault elsewhere. Now, I don't know what value that cap that we took off was, but it's probably, we could go the Soldering route and not replace it, and that would be fine. But I have loads of donors here that have 5V circuits and similar size capacitors, so I'm just going to put a cap that I know is good for 5 volts back on. Okay, I found a cap that I think will do the job, so let's just drop that on. Add the tiniest amount of flux. We don't want to go overboard with flux. We only literally need a drop. Be easier to clean up. Cool, and we can just remeasure that one last time. And yep, no short. Perfect. So we no longer need this cable attached. Let's get rid of that. Again, add a tiny bit of flux. And let's just make that look nice. Try and hide the evidence that we were injecting voltage there. It's got quite a high thermal density, so I'm actually going to add a bit of heat from my heat gun at about 200 degrees, just to help my soldering iron along. There we go. And let's do the same up here, where I first injected, thinking that the main rail was short. Perfect. Cool. Let's just have a look at this liquid metal a second. There we go, get rid of some reflections. You can see a lot of the liquid metal has escaped. So I'm gonna just try and regroup that. Get it back to the middle where it's meant to be. I don't really like liquid metal. I'm gonna see what temperatures this thing gets, and if it's not getting very good temperatures, I'll go back and clean all this up and replace it with PTM 7950. I think liquid metal is a really bad idea in laptops, to be honest. I've seen quite a few that have had spillages and damage as a result. And the ASUS stuff, it tends to dullen the core, the die a little bit. And I've actually seen it start to eat away at the heatsink as well, which reduces its performance quite significantly. So we will check the temperatures after we've got this back together. I'll probably do that off camera. But for now, I'm just going to put that back in the middle. I'm going to reapply some thermal paste to the GPU, and we will get it tested. Let's try and get the cables out of the way. And ASUS have made it very difficult to plug in this fan cable. We should have, yeah. You know what I'll do? I will remove the fans from the heatsink assembly first and clean them. The heatsink out of the way, the fans are way easier to plug in. I haven't cleaned them perfectly, but we don't know if this liquid metal needs replacing yet, so we can clean them up a bit more later. Left the keyboard cable under the board, that's not very good. And I've also left stickers off as well. I really have not had enough coffee this morning. That goes there. That goes there. Okay. Let's try this one last time. The heatsink is on. Let's get some screws in. Okay, I don't care about the rest of the cables or the SSD right now, so I'll go back and install those a little bit later. Let's plug battery in and put cover on. Plug the charger in and see if it works. Oh, I've not even had to hit the power button. That keyboard's already lit up. It's going to take a while because it's had its CMOS reset. It's had all its power drained from it, so I'll leave it for a minute. Weird, I'm not sure this is working. Maybe reseat RAM's going to fix this. Have I left it long enough yet? I don't know. Yeah, I don't think this is working. Okay. Let's try it just with one stick of RAM in one slot. Screen's definitely plugged in, so this should work. I'm just going to leave that for a little while, come back to it and see if it's displayed. Okay, thank God, it's actually displaying. This laptop has gone wrong in almost every way I can conceivably think. But here we go. It is working. It's running a little hot at 70 degrees, so I probably will go back and replace that liquid metal. But otherwise we're all good. I'll make sure I can get this thing working with the other RAM stick back in it. But yeah, looks like it's working, so this one's going to go down as a win. This one was a bit of a roller coaster. Obviously I first misdiagnosed it as a bad 20 volt rail because I measured the wrong point. And then my bench power supply nearly sent 20 volts into the 5 volt rail, which would have destroyed this board pretty badly. So I'm quite grateful that this has all worked out, because it could have gone a lot worse. Anyway, I'm going to say thanks for watching. Hit that like button if you liked watching me fumble around and make mistakes. And subscribe to see me fix more laptops. Goodbye.